Here we got the 2019 Higher Paper 2 question 3. The focus of this question is all on vectors and vector calculus, looking at vector journeys and dividing vectors up into ratios. So what we're going to do here is we're going to break down two parts and we're going to see how to accomplish each of them. First one is expressing a vector in terms of other vectors, so different vector pathways. And the second one is looking at a vector being divided in a certain ratio and how do we then calculate a vector journey taking this into account. So first one, part A, let's start with this bit here. So I want to express the vector b to e in terms of p and r. Right, first thing we have to do is establish all the properties of the pyramid that we've got, and then what we want to be able to do is take that and relate it back to the question. Now all the information will be contained here, whether it's just a diagram or whether it's information written in this format here. So we're told the vector a to b is given by p, the vector a to d is given by q, and the vector a to e is given by r. First thing we have to do is find the journey we want and represent it using the vectors we know. Now, one thing to remember, the vector b to e, c to e, and d to e, they are not the equivalent of the vector a to e. They're not parallel to each other. Parallel vectors have the same journey. However, each of these, because it's a pyramid, square-based pyramid coming up to the top, none of these ones are parallel to r. So we can't name those vectors as r. So we can't say b to e in terms of p and r is r. That doesn't work. What we have to do is find a journey that involves the vectors we know that will get me from here to here. Well, that journey is if I go along this vector this way and then go up here to there. So what I can say, so for part A, is that to go from b to e, initially what I can do is go from b to a and then go from a to e. What that'll do is that'll take me the journey I want. Now we know the vector a to b, but I'm doing the journey b to a. So that's backwards along the vector a to b. So if a to b is p, that means b to a is negative p. So I know then that that's negative p for that one, and then the vector a to e is given by r plus r. Just like that. Again, underline them as we would with our vector notation. So there you go, I've got b to e in terms of p and r. It could be negative p and r. I could have written it as r minus p if I really wanted to as well. 6 2/3 to be honest with you. Second part is expressing the vector e to f in terms of p, q, and r, but I'm told that the point f divides b to c in the ratio of 3 to 1. So the point f divides this in the ratio of 3 to 1. Yeah. So what I want to do is find e to f in terms of that. So you can imagine that I'm going down this way to there. So that essentially is the journey that I want to make. So in order to do that, I have to figure out how to get there. Well, the journey I could make is e to b and then b to f. So for that one, I can initially start by saying, right, to get from e to f, what I want to do is go from e to b and then add on b to f itself. Now b to f splits the vector b to c here, and it splits it in the ratio of 3 to 1. So that means to go from b to f is to actually go 3/4 of the way along the vector b to c. So I can then rewrite it again as the e to b plus 3/4 of the vector b to c. Now, I know what e to b is. I figured out b to e earlier on. E to b is just the reverse of that, as we said earlier, with b to a being the reverse of a to b. So if b to e is r minus p, that means that e to b is minus p plus r. So that's going to be minus p plus r for this first part. What I now need to do is figure out 3/4 of b to c. Now I've not been given b to c. However, b to c is parallel to A to D. We know that because it's a rectangular base pyramid and opposite sides in a rectangle are parallel. What that then means is the vector B to C is equal to the vector A to D. So that means it's equal to the vector Q. So I've then got to add on 3/4 of this vector B to C, which is Q, so it's then plus 3/4 of Q. So that there is the vector E to F in terms of P, R, and Q right there. So it's got one part of each, and we've used the fact that we've got parallel lines, parallel vectors, and properties of our shape, as well as splitting one of the sides in a set ratio in order to be able to get the answer that we want. So there we go, that's the answer to these two parts of the question. First one's worth a single mark just for getting the answer. Second one, worth 2 marks, firstly for knowing the journey that we've got to take, and then secondly for getting the answer. Now this first one can also be given if we get to a final answer. It's implied that we know the journey. So if we know the journey to take and get to here, great, we're going to get that first mark as well, no matter what. So remember all your properties of vectors, parallel lines, and how to make a vector journey, and how to make it effectively in terms of other vectors that we know.